I am going to start the new topic, that is refraction through prism. Okay, now we have to see the refraction through prism. Let us suppose it is prism. It is prism A, B, C. A ray of light is incident on surface AB. It is normal, and it is angle of incidence I. Since in this case, ray of light is moving from air to the glass, means it is rarer medium and it is denser medium. So, ray of light will bend towards normal, so it is bending. And this ray of light is incidenting on surface AC. Is it clear? And it is normal. Let us say this point is P and this point is Q. Means firstly, a ray of light is incident on surface AB at point P, and from P after reflection through this surface AB, this ray of light is incident at point Q on surface AC. Now, since in this case, this ray of light is coming from denser medium to rarer medium, so it will deviate away from the normal. Is it clear? It is angle of incidence I, and it is angle of reflection R1, and it is angle of incidence for this surface, let us say R2, and it is angle of emergent E. So we are saying that this ray of light after reflection by this surface AB bending towards this direction, and after that it is emerging in this direction. If let us suppose I am removing this prism AB from the path of this incident ray, so what will happen in this case? This will follow this straight line, means image in this direction. But we are keeping this prism in the path of this incident ray. So this incident ray is deviating in this direction. Means this is the emergent ray. I am just increasing in this direction. So this angle is known as angle of deviation. Angle of deviation. Means angle of deviation is the angle between this incident ray and emergent ray. Is it clear? Let us suppose this point is M and this point is N. Is it clear? Now this is angle of prism A. I am taking a triangle step 1. I am taking triangle P, M and Q. Triangle P, M and Q. We know that the sum of angle of triangle is 180 degree. So here R1 plus angle P, M and Q plus R2 will be how much? Tell me. 180 degree. So from here we get angle PMQ will be equal to 180 degree minus R1 plus R2. Now let us suppose this trapezium APMQ. So I am taking trapezium PMQA. The angle A plus angle PMQ will be how much? 180 degree. So I am writing here angle A plus angle PMQ will be equal to 180 degree. So from here angle PMQ will be equal to 180 degree minus angle A. It is equation number 2. So from equation 1 and equation 2, we what we get from equation 1 and 2? We get this will be 180 degree minus R1 plus R2, and this will be equal to 180 degree minus angle A. This will be cancelled out, minus and minus will be cancelled out. So angle A will be equal to R1 plus R2. It is equation number, let us say, 3. Equation number 3. Now, step 2. In triangle, I am writing here, in triangle NPQ. Look here. This ray and this ray, or this line and this line, are intersecting at point P. So this, if this angle is I, so this angle will also be I. Since it is angle R, so this angle will be equal to I minus R1. Is it clear? And at point Q, this line and this line are intersecting, and it is angle E. So this angle will be E. So this angle will be equal to E minus, writing here, E minus R2. And in triangle NPQ, this delta is the outer angle. So delta will be equal to outer angle of any triangle is equal to the sum of two interior angles. So in this case, this I minus R, delta will be equal to I minus R1 plus I minus R1 plus E minus R2. So it will be equal to I plus E minus R1 plus R2. This will be your delta. For minimum deviation, for minimum angle of deviation, R1 will be equal to R2, and angle of incidence is equal to angle of image Z. So delta minimum will be equal to I plus I minus R plus R. So this will be equal to, delta minimum will be equal to 2I minus 2R. So from here 2I will be equal to delta minimum plus 2R. 2I will be equal to delta minimum plus 2R. But from equation 3, what is equation number 3? Equation number 3 is angle A is equal to R1 plus R2. So I'm writing here, angle A will be equal to R1 plus R2. But R1 is equal to R2. Let us say it is R. So I am keeping here the value, angle A will be equal to 2R. Angle A will be equal to 2R. So 2I will be equal to delta minimum minus or plus 2A. Plus 2A. So from here we get I is equal to delta minimum plus angle A upon 2, and from here angle R is equal to angle A upon 2. So what is Snell's law on this surface? Snell's law, writing here, Snell's law states that I am applying here Snell's law. Snell's law, mu will be equal to sin I upon sin R, and this will be equal to, I am keeping here the value of sin I, sin delta minimum plus A upon 2, and this will be equal to sin A by 2. And when angle is small, so sin theta will be theta. So in this case, I am writing, when angle is small, too small, when angle is too small. So in that case, sin I will be equal to angle I and sin R will be equal to R. So in this case, mu will be equal to sin I upon sin R, or it will be I upon R. So from here mu will be equal to, I am keeping the value of I, that is equal to how much, tell me? It is equal to delta minimum plus A by 2 upon this will be A by 2. This will be cancelled out, 2 by 2 will be cancelled out. So it will be, mu will be delta minimum plus A upon A. Multiply here, it will be mu A sin, delta minimum plus angle A. So delta minimum will be mu angle A minus angle A. So I am taking angle A as a common, in bracket mu minus 1. This will be delta minimum or angle of deviation. This will be angle of deviation, delta minimum, angle A mu minus 1. Okay. So the next topic is the microscope. Microscope is a device which is used to make the larger image of any object. Is it clear? So first of all, I am going to describe the simple microscope. Simple microscope consists of a convex lens. So it is your convex lens. It is convex lens and it is principal axis. Now let us suppose an object AB is kept in front of convex lens, which is less than the focal length. Means object is kept between the focal length and the optical center, or very near to the focal point. Now one ray is falling parallel to the it is optical center, parallel to the principal axis. After reflection, it will pass through the focal point, and one ray passing through the optical center. So I am here, the reflected ray appear to intersect. So image A dash B dash of an object AB is formed. Okay, the image is virtual, and we are saying that it is larger in size. So what is magnification, my dear students? We know that magnification is V upon U. We know that 1 upon lens meter formula is 1 upon F is equal to 1 upon V minus 1 upon U. So what will be 1 upon U? 1 upon U will be equal to 1 upon V minus 1 upon F. So I am keeping here the value of 1 upon U. So we get V 1 upon V minus 1 upon F. This becomes 1 minus 1 upon F. If F is V upon F, V is equal to minus V, very near point. So this becomes 1 plus V upon F. Now let us suppose object makes an angle theta naught on the eye. Is it clear? So it is object AB and the height of object is H, and this is distance D, that is the near point, and it is angle theta naught. So what will be tan theta naught? Tan theta naught in this case will be equal to H upon D, and this will be nearly equal to, my dear student, theta naught. And let us suppose angle made by image is theta I. Is it clear? So tan theta I will be equal to H dash upon minus 3. Is it clear? We know that magnification M is equal to H dash upon H, and this will be equal to V upon U. So from here H dash will be equal to HV upon U. So I am keeping here the value of, so the value of tan theta I will be equal to, I am keeping the value of H dash here, it becomes HV upon minus V into U. This will be cancelled out, finally we get H upon U. Now object is kept very near to the focal point, so U will be nearly equal to your F. So this becomes, it is minus F, it becomes H upon F. And this tan theta will be equal to, nearly will be equal to theta I. So magnification, angular magnification will be equal to theta I upon theta naught. So it will be f upon d upon theta I upon, it will be theta upon. This is the case of simple. It is the case of simple micro scope. Simple micro scope. Now, dear student, we are going to see the compound micro scope. So I am writing here compound micro scope. Look here. Compound microscope consists of two convex lens. One is the objective and another one is the eyepiece. So compound microscope. This is it is objective and it is your eyepiece. It is your eyepiece. Let us say it is your eyepiece. And it is principal axis. One object is kept in front of the objective. Let us say it is AB. So this ray will fall parallel to this principal axis. After reflection, it will pass through the focal point of this objective lens, and one ray I am falling which passes through the optical center O. So here the image A dash and B dash is formed. Finally, this ray will, after reflection, pass through the eye. Let us suppose it is your eye, and they will intersecting here. So the image A double dash and B double dash is formed. That's clear now. In this case, what will be magnification? The magnification for objective lens and magnification for the eyepiece. I am writing here the magnification of MO, that will be equal to how much? Tell me. MO will be equal to, I am taking this triangle, let us suppose O, this is M and F. O, this is point M, I am writing here O, M, and this is your F. Let us suppose F. And this triangle A dash, B dash and F dash will be what? Tell me. They will be congruent. So in this case, H dash upon H will be equal to L upon this will be your F. L upon F. Is it clear? It is equation number 1. Now we know that ME, that is the magnification of this eyepiece, will be equal to 1 plus D upon FE, and it will be nearly equal to D upon FE. So the magnification of objective and the eyepiece M will be equal to MO into ME, and this will be finally L capital D upon FE into FO. Is it clear? So it is the magnification of compound micro. It is compound micro scope. Is it clear? This scope also consists of two convex lens. This lens is known as objective, which is in front of the object, and it is eyepiece. It is clear? This ray of light is coming, which after refraction passing through this way, and this is the ray which is passing through the optical center. Both the rays are intersecting here. So image forms at point A dash and B dash, which acts as a object for this eyepiece, and finally we obtain the image. This is the angle alpha and it is the angle beta. So magnification M will be equal to beta upon alpha, and this will be equal to tan beta upon tan alpha. So in this case, we get the value of tan beta, and tan alpha is tan alpha will be equal, tan beta will be equal to h upon ft, whereas alpha will be equal to h upon fo, and it finally fo upon ft. So it is the magnification of telescope.